Alright, welcome to video 2. I said it before, I'm going to say it again. I don't script these, so it might get a little rambly. The point of this video is going to be a kind of broad strokes node tour, a tour of what nodes are available in the application. I'm going to start off with shapes, and then I'll talk about some of the other ones. I'm probably not going to hit every single shape here. I'm just going to hit the high points. And in video 3, I'll talk about the custom nodes because they take a little bit of special handling here. So I'm going to delete everything here and let's dive in. So as far as your basic shapes go, you've already seen the circle, which is exactly what it sounds like. Let's go in roughly alphabetical order here. I'm going to skip a few for reasons that'll become clear later. The arc is, I hope, exactly what it sounds like. It draws an arc. In this case, an arc from 0 to 90 degrees at 150 pixels, a radius. You can enable the pie slice if you want it to draw a line from the center to each corner or edge or point, end, whatever. And you can adjust where you want the angle to start. So in this case, it starts at 20 degrees from top dead center and goes around plus 90 degrees. Now, at the top here, you'll see that there's a start, sweep, and from to mode. And that basically makes it so that it changes how that's calculated. So I could go from 10 degrees to 60 degrees, or I could go start at 20 degrees and go plus 90 degrees, or minus 10 degrees. And that's how that works. It's just two ways to get the same result, but it depends on your mental model here. Again, there are markers for the arc, in this case start and end, so like it'll put a marker at the start and a marker at the end, and they can be the same or different depending on what you want. Just a note, fill does not happen until you turn on pie slice, because if you don't have pie slice turned on, it's an open edge and fill is meaningless. So that's just a thing to know. So that's arc. Burst is essentially a bunch of radial lines like a sunburst. You can define an outer radius and an inner radius. In this case, this is 160, this is 120, or 140 rather. Or you could do the same method as you could with the polygon, or the star, I think it was, where you set a base radius and then it extends, in this case, 10 pixels past and 10 pixels before, like inward, and you can change the same modes that you could there. And just like the arc, you can start the sweep and have it extend a certain number of degrees past that, so like start at 10, go plus 90. You'll notice here, though, that this isn't actually 90 degrees, and I'll explain why in a second. But you can also do the from and to, so like from 0 to 90, or you can say from 30 to 90. And there's this checkbox called inclusive end, and what that does is if you happen to go from, say, 0 to 360, despite the fact that there are 5 spurs, only 4 show up. And the reason for that is because the first and the last are piled up at the start, because 360 is the same as 0. So if you turn off inclusive end, it kind of redistributes them as though, it distributes them evenly across the thing. So that's why that exists. And that's why it wasn't showing up from 0 to 90. So that just, if your distribution of spurs looks a little weird, that might be why. Again, you have your marker start and end. Start is here, end is outward. So like, that's why there are 2. Oh, that's a bug. Angular distribution should be inside of more. I will fix that. So that's the burst. Circle, pretty straightforward. From path and glyph, I'm actually going to skip for right now. And I'm also going to skip the knot, because it becomes easier to explain after I explain another one. Line is exactly what it sounds like. Give it a start point and give it an end point, and it will draw a line between those 2 points. So like negative 50y, or you can define them in polar coordinates. Say, from the center, you go 100 pixels in the 135 degree direction, and that'll be your endpoint. It's a little confusing. I don't actually use a line that often, but, you know, it's there. Polygon, you probably already saw, but you can define a polygon with, you know, n number of sides, anywhere from 3 to, I think, 64, which does not look... It looks more like a circle than it does a polygon, but, you know, I had to give it an upper range. Pretty basic shape here. Now, the poly ring is essentially the same thing as a polygon, except it's got a hollow spot. So if I actually give it a fill here, it's a little easier to tell. It's cut out in the middle. Now there's a couple ways that you can define what is the outer and inner radii here. You can do the inner and outer, just like the star. So you define, say, an outer radius of 120 pixels and an inner of, say, 80 pixels, and that goes from the center to the point. Or if you change it to circumscribe mode, you can say this is 0 to 80 from center to edge. Let's just keep it there for the sake of simplicity. But there's also the spread mode. And the way spread works is similar to how spread works on the star, where your base radius is defined by this, and then the spread is a kind of plus or minus, depending on your spread align mode, from that radius. So like this outer point is, if I change this to 100, this outer point is at 110 pixel radius, and this inner corner is at 90 pixels. Or, you know, I can change the inward and outward and whatnot. What's new for the poly ring, however, is the expand mode. And the reason for that is because this spread, which is 20 pixels, actually measures between these 2 points. So like this inner point and this outer point. Now, that's fine, but that means that the distance between these edges is actually less than 20 pixels. And, you know, it might be important to you that you want the edges to be 20 pixels apart instead of the corners being 20 pixels apart. That's what this edge mode does. So now I switch that over to edge, and these edges are 20 pixels apart instead of the vertices. That's basically what that does. So that's poly ring. Rectangle is fairly straightforward. It's a rectangle. If I need to explain what a rectangle is to you, I can't help you. Ring is kind of like the circle, except it's an annulus. It's a ring. It's a ring. What do you want? Spiral is pretty much exactly what it sounds like. It's an Archimedean, or it's an approximation of an Archimedean spiral. You can set the inner radius and the outer radius just like you can any other one. So like this is 90 pixels from the center, and this one is 180 pixels from the center. Or you can use the spread mode just like the other thing. I actually don't have the spread mode. I should add that. I will add the spread mode to this, so that'll be a thing. And also these are swapped. Outer radius should be first. I'll fix that before this video goes live. Anyways, so much like the arc and the burst, you have the start/sweep or the from/to, and that just lets you define, you know, where do you want them to start or end, or do you want them to start in a place and go a certain number of degrees around. That's what that does. That's a spiral. Star you already got an introduction to, so there's really not much to it beyond that. You can define the number of points to it. You can give it an outer radius and an inner radius, or you can give it a spread and a main radius and whatnot. There you go. I jumped over the polygram, and that is because it's easier to think of this one after you get used to the polygon. What the polygram does is, at first blush, it looks like a polygon. Except, if I were to, say, do a 7 here, I can define the number of vertices that a line will skip. So if I set this to 1, you'll see that it draws a line by going from point 1 here. It skips 1, and then instead draws a line to the next one. Again, it skips 1 and then draws a line to the next one. Or I could set a skip of 2, and it, skips 2 vertices and then draws a line. That's what a polygram does. As you might have surmised, the knot is essentially the same thing, but with a band. So like, if I set this to 7, and I'm going to set a background color on here, or a fill color rather, you can set the skip on this, and again, it will kind of have it's basically the ring version of a polygram is what the knot is. The only other thing that's worth noting here is that there is an option, there it is, under more, for remove crossings, and that basically just solidifies the internal edges. There's the same thing on the polygram as well. So if you want to not have those crossing lines, just hit remove crossings, and that'll let you do that. Also worth noting, and this is true on the poly ring as well, the inner corner radii is distinct from the outer corner radii, so you can have different shapes, different corner shapes and corner radii on the inside corner or the outside corner. That's might be worth knowing. So that's the knot. Let's actually do the spiral again, and I'm going to pull in this text path. So if I were to, I'm actually going to do this, and I'm going to pull in a layers and jump that into there. Let's actually rearrange that to there, and then this. So this spiral here, and I'm only doing this as a representation here, you'll see that some of these shapes have a yellow path output, and what this does is it's kind of like a shape, but it's used to kind of dictate the shape of other things, so to speak. So like, this is going to put the text along the path. So if I do, say, Futhark, I'm actually going to reduce the opacity of this to like 10. More like 30. There we go. You can still see it, but now the text is the important part. You can see that the text follows the path. So you can plug in any path in here, whether it's a circle or whether it's a polygram or whatnot. But it needs a path to follow along. You can change the font size, you can change the fonts. I've got a couple in here. If anyone has any ideas for more or wants to, throw more at them, go nuts. I just picked up a bunch of cool looking ones on the internet. Anyways. Let's keep it on Futhark. You can change the letter spacing, and there's a whole bunch of alignment tools and where you want to put it on the path. So like halfway along the path, you can bump it up by 12% or by a quarter inch from the center. You can change the alignment on all these, and there you go. And of course you can reverse the path if you wanted to face outward instead. That's what that does. So the next node I'm going to talk about here is from path, and I mean this is going to be exactly the same thing for now. The from path basically takes a path and converts it into a shape, which I'm sure might seem redundant at first, but when we get into some other operations that use paths, it becomes a lot more useful. We'll circle back to the from path in a minute. And then you have glyph. Glyph is a bit of a hard one to explain. The glyph is basically the way that you can inject custom SVG paths into a shape. If you're familiar with SVG files, this is essentially your path D attribute, and you can set up a view box to kind of tell the dimensions of the thing, and then put that in as a single shape to your circle here. If none of that made sense to you, this is probably not the shape that you'll be using all that often. It's more there for the extreme technical flexibility and custom glyph injection. So if that didn't make sense, don't worry about it. So that's the shapes. Let's move on to the math nodes. Or actually, better yet, let's move on to the primitives. Primitives are basically your raw values. So like you saw me tweaking dials on angles and whatnot. This is a way that you can be like, hey, I need a 60-degree angle that I'm going to use in multiple places. So I can just enter it here and wire it up to a bunch of different sockets. Same thing with all of these. Boolean is your true-false value. Color, if you want to reuse the color without having to type it in multiple places, just hook it up to one of these. An enum, or an enumeration, if I actually pull the, say, polyring back, these radio buttons, these different mode options, are actually enums, or enumerations. And the way that this works is you can wire up an enum to anything that accepts an enum, and you can kind of give it its own custom label. So like option A is essentially the same as inscribe, and option B is currently middle. And if I add another option, option C will be circumscribe in this context. So it's just a way to have a set of values as a drop-down. You probably won't use this much outside of specific outside of subgraphs or custom nodes, unless you want to set multiple like outer scribe modes to or different scribe modes. That'll be a thing. I've got a list of all the different presets here. So like there's your scribe modes, so you can just click that and then the drop down will match up, or your text aligns or span modes or whatever, blend modes if you want to plug that into a layer, what have you. This is probably more advanced usage, but that's the thing. Float is your decimal number, so like 0.5 or 0.25 or 3.0. That's a float, a floating point number. An integer is exactly what it sounds like. You can be like 1 or 5, but no 0.5. It'll actually... I shouldn't be able to type that. That's a bug. I'll fix that before I upload this. So integers should be solid numbers, no decimal points. You'll notice that there's a drop down for conversion, and the reason for that is because you can actually pipe a float into a number, and it'll be like, hey, cool, how do you want to round it? You can kind of go away from 0 towards positive infinity, away from 0 towards negative infinity. There's a whole bunch of different rounding modes that will say, given a float, how do you want me to convert this into an integer? Your typical one is actually, I think, half ceiling, which is under normal circumstances, round to the closest integer, but if it is 0.5 or ends in 0.5, round towards positive infinity, I think. So like negative 5.5 will get rounded to 5, I think. I can't remember which one that actually is. Half expand, I think, is towards... Oh, wait, hang on. Ceiling is towards positive infinity. Floor is towards negative infinity. Truncate is towards 0. Expand is away from 0. That's how that works. And then the half version is go to the closest, but at 0.5, do that thing. So that's the rounding modes. Anyways, and then you have things like length. So like you can give it a length of 5 inches. And there's another conversion thing. So you can pipe a float into it. And it says, what does this 5 mean? Is it 5 pixels? Is it 5 points? 5 millimeters? this is how you pick that. Random seed just outputs an integer, and you can just click this number or this button to generate a random number. There's a couple effect filters that use this, so that's the thing. And then your token's length is the same thing as the stroke dash. So like you got 10 pixels, 4 pixels, say, for example. I just needed a way to plug in that specific data type into stroke dash. So that's why that's there. So those are your primitives. Moving on to logic. This is essentially Boolean logic, and, or, XOR, whatnot, or you're greater than or equal to. You can test values, say, return true if this length is greater than 5 millimeters, stuff like that. I'm not going to get too deep into what this means. If you're not familiar with Boolean logic, I would recommend checking out Ben Eater's video on logic gates. That's essentially what these are. This is essentially an AND gate or a NOR gate. Those are your logic gates. However, I will bring up two special kinds of nodes here, which is the condition and the switch case. The condition, essentially, and the best way to explain this is actually to just wire it up. Let me get a color, and I'll clone that. Say red or green. So the condition essentially says if some condition is met, then, in this case, paint the thing red. Otherwise, paint it green. So because this is checked, the condition is true. So I can say, well, if it's not true, it's going to be the else case. Now, you're not limited to the colors with this, obviously. You could switch anything in here, like shapes. You could say, if this checkbox is true, give me a circle. Otherwise, give me a polygon. Anything like that in there. Now, chances are you're probably not going to use this too much in your main graph. You're probably going to use these more in subgraphs, and that's fine. But, that's a thing. The switch case is kind of like the condition, but on steroids. You can choose multiple options, and you pick this through an enum. So, like, I could wire in red and green, and I'm going to do the same thing and pipe it into fill. And I can pull in an enum primitive and say this. So using this drop down, I can control which output I'm pulling from here. So I could be like option B, which is green, or I can control it through option A. That's the red, because that's linked up to the first option here. Just to note, these labels don't actually mean anything. They're just convenience labels. You can just make it easy to remember what they are. And if no condition is met, like if there is no, or if you have an option that is out of bounds here, it'll flow into the default. So if I make this, say, gray. So for example, if I choose option C here, there is no option C, or rather there is no third option here. So it'll just fly back to the default by default. That's what that means. For programmers out there, this is exactly what this is. It's a switch case. Anyways, so that's logic. Meta, I think I've already introduced the notes. This is just a way to document your graph if you'd like. You've also got the container, which I think I showcased in the first video. You can move this around. It kind of gets stuck behind things sometimes, and what this essentially does is it lets you drag multiple nodes together and keep them contained, and you can color assign them. So if you want to keep them organized by color, that's a good way to do it. And then the preview node, which if you have a subgraph that has a shape in it and you just want to see what that shape looks like in isolation, you could just pipe it into the preview and it'll display it right here in the thing. So like this circle. There you go. You can preview it right in the graph. Very useful. Math nodes. So there's kind of two flavors of math nodes, or really three, I suppose. Let's talk about these path ones first. Now, I already mentioned paths, so what I'm going to do is pull in a circle and a star. I'm going to increase this radius to 150. So we have this star, ta-da, and we have the circle. Okay? Now, you'll notice that if I combine them just like this, they're independent of each other. They overlap each other. Now, what I could do instead is take the path from the circle and unify it with the star, the path from the star, and this is where this from path node comes in. And if I pipe this to the output, you'll see that it collapses into one shape. It unifies them. Exactly what it says on the tin. Similarly, you can do path subtract. So I'm going to take the circle, take the circle path, and I'm going to subtract the star path from it, and you get this shape. And you can style this just like you would any other shape. Ta-da! Or you could swap them around, and you've got the star minus the circle. These are essentially your shape booleans, not to be confused with true-false booleans, which is why I loathed to call them that. But there you go. So this is the circle intersected with the star. And then you have exclusion, which is a weird one, but when you need it, you need it. The exclusion is essentially give me everything that is not in either of them. It's your exclusive OR, but in path form. So it's the circle with plus everything that is in the star, but not that which is within both. That's what the exclude does. There's also divide and heal. Heal essentially just self-unionizes, so like that's actually how the not works with the remove crossings. That's a self-heal. It just basically fixes any self-intersections of a path. And then divide essentially takes the path and splits it up into its constituent parts. Like so. So you'll see that it's actually got a stroke in there. Now, technically, these are 6 different shapes, just with 0 gap between them. So you might get a little wonky here and there, depending on what you're doing. But, that could actually be helpful. I don't know. I put it in there because it was easy. Moving on to your other math nodes. Let's pull in a polygon here, and I'm going to take care of this from path. And let's say for a moment that you have this polygon, say I make it a pentagon, and you want the radius of the circle. Oh, I got a text message. Stand by. Excuse me. Hang on. Okay. Anyways, I've got this polygon here, this pentagon, and suppose I want the radius of the circle to be, say, 10 pixels less than the apothem of the pentagon. Well, there's no real good way to do that. Shush, I need to turn off my phone. I'm popular tonight. Say hi to the roommate. Hang on. Where's my do not disturb thingy? Stop it. Okay. I just got this phone a little while ago, so I don't know the interface. Okay, anyway, sorry about that. So suppose I want this circle to have a radius that is, say, 10 pixels less than the apothem of the polygon. The apothem, as a reminder, is the distance from the center to the edge, the closest edge, such that it is 90 degrees along that edge. Now, there's no real good, easy way to do this mentally. You could do the math and everything and then just plug it in. Or I could just subtract like this. So like I take the apothem radius, I put that in A, and I'm going to take a primitive of length and say, what did I say, 5 pixels? 10 pixels? We'll say 5 pixels now. And we go A minus B, and we just plug that into the circle. And now, no matter what the radius of the polygon is, the radius of the circle will always be 5 pixels less than the apothem. Or I could do this, and I'm going to just say negative 5 pixels, which is essentially an add. So now the radius of the circle is 5 more than the circumradius of the polygon. This is really handy if you want to just do things that are based off of other things and whatnot. There's a whole bunch of other math nodes in here. I'm not going to get too much into it. I'm sure you can figure these out. Some of them take in all sorts of different kinds of values, like the add can take in an angle, a length, an integer, or a float. But like the cosine function here, where is it? There it is. Cosine can only take in a float, like, or an angle, or an integer, because a length in a cosine doesn't actually mean anything. So yeah, just have fun. I'm not going to bother with going through all these math nodes. And last, we have these special effects. And these are just me having fun. So like, you could give a thing a brush stroke, and it looks a little sketchy. And this is where that random seed comes in, by the way. You can actually take this random seed and plug that into there and get more variations. So yeah, there's the brush stroke, or you could do the glow. And the glow can actually double as a drop shadow by changing the offsets, but that's a thing. There's also the pen stroke, which I think is actually my favorite. And then the pencil. So yeah, those are all the nodes in this. Oh, I haven't done the collections. That's probably the most important one. Okay, so collections. I've already introduced you to the layer, so I'm going to skip that, except to say that you can do different blending modes on these. And there's an isolate blending option in here, which basically means, do you want to do all the blending on this layer group on its own, or can these leak out? So like if I set something to difference, it will invert everything up the entire layer stack. This is a way to basically do all the blending internally inside of this layer node. Experiment with that. Just trust me. I've also introduced you before to the polygon array, but I'll go over it again. If I pull up a shape here. Oh. A polygon array is essentially a way to distribute shapes around the virtual, or the vertices of a virtual polygon. You can set the radius of that, and there's a couple options on whether or not you're aligning the shape to a path, which doesn't make sense in the context of a circle, but c'est la vie. So, polygon array, there we go. Let's talk about the path array. Now, the path array is similar to the polygon array, except instead of working on a virtual polygon, you can plug in a path to it. So in this case, a spiral. Now, of course, I can tweak the shape of the spiral, and I'm actually going to throw a layers in here just to visualize said spiral. There we go. See, you can see how those circles are distributed across that spiral. And let's increase the count to say 9. There's different spacing modes, so you can be like space between or space around, which gives the start and end a certain amount of padding, or you can do a space after, space before, or you can give it a fixed spacing, so like maybe, I don't know, 3 inches or half an inch between each instance. Or you can do that but centered on the path, or do that so that it's half an inch between each instance but is based at the end of the path. All those options are there, and there's a couple more options that I encourage you to play around with in here. And next up is the radial array, which is much the same thing. I'm going to get rid of that spiral, and again we can do the circle. And the way that this works is it's similar to the burst. You can say, you want 5 shapes distributed around an arc from, say, 0 degrees from top dead center, extending plus 130 degrees, or you can offset that by 10, or you could do the from to and do the same thing. So like from 10 degrees from top dead center to 90 degrees from top dead center, and that's how that works. Now, arrays are cool, and I'm gonna put in a polygon array again, and I mentioned this in the previous video, but I'm gonna go over it again. The real power comes from when you use the array items with the sequencer or an iterator. So let's take the sequencer, and instead of saying, I want 5 circles, maybe I want a circle and a polygram, and let's plug that into there, and take the sequence and plug it into the sequencer, and there we go. Now it goes circle, polygram, circle, or whatnot, and I can add another one, and I can add another one to say, I don't know, a ring. Sure. So yeah, you can repeat different shapes along the sequence of an array. Now, you're not entirely limited to just discrete values using the sequencer. In this case, you can. And by the way, like I said before, you don't necessarily have to use shapes. You could give the circle different diameters based off of where in the sequence it is. But a more utilitarian version of this, I think, is actually to use the iterators. So I'm going to clear all these out, and we're just going to go back to having 6 circles along the array. And let's use a color iterator. Now, a color iterator actually has 2 uses. You could do a simple lerp, so like this first color might be red, and let's say the second one is green, and you could be like, okay, give me a color that is halfway between a red and green, and that'll be the fill color of the circle. And yeah, it looks fairly ugly, and there are other things you can do to kind of make this not as ugly, but we'll get to that in a second. And you can, or maybe you want like what is 25% between these 2 numbers or these 2 colors, or maybe you want to add a third color in here and be like, give me this blue, and we're gonna set that to a position of 100. So the way that this gradient, you can't see the air quotes that I'm using, is red to green to blue. And you can then be like, what's 75% along this gradient? And you can just output that color. However, that's only one use of the iterators. The other one is if you actually give it a sequence. So I'm going to give it the sequence and plug the sequenced output to this fill color. And you'll see that for each iteration, it actually distributes the color along this gradient. So it starts at red, goes to green, which is actually somewhere over here, I think. Yeah, see, there it is. And then goes to blue. So it lets you loop through or sample along a range of colors. And there's iterators for angles and floats and integers and lengths, so you can, you know, interpolate across a spread of values using a sequence for all sorts of things. So, for example, if I take this length iterator and I want to go anywhere from, I don't know, 10 pixels to 20 pixels, well, I can take that same sequence, throw it into there, and make that the radius. So now it samples along anywhere from 10 to 20 smoothly along the iteration. So you can do all sorts of things like that in there. Now you could do the same thing with sequencer. So like, for example, if I wanted to alternate between, say, 10 pixels, and I'm going to clone this and make this 20 pixels. I'm only going to put in 2 here because that's just going to be easier. Grab the sequence, throw it in there, and then make this the radius. It'll undulate because that's, you know, you're basically saying the first iteration uses step 0, the second iteration uses step 1, the third iteration uses step 2, but there is no step 2, so it wraps around to step 1. Or at least it does because the mode is set to wrap. You could set it to truncate, or you could set it to clamp, or bounce, what have you. And then there's all sorts of other parameters that let you tweak that. So these are just really powerful ways to mess with iteration. That's pretty much how iterators work, and the sequencers work, and the arrays work. This is probably one of the most powerful tools in here. So if I were you, I would get familiar and comfortable with these, because this is what's going to cut down on a lot of repeated work everywhere. Excuse me. We also have a long path, which is pretty much exactly how it sounds. Take a shape, and I'm going to use my trusty spiral here, and we'll wrap this around a few times and take this path, and it basically says how far along this path do you want this circle to go. And I'm going to just display this spiral again. So you can be like, you know, 20% along the path, and that's where it lands you. It's kind of like the path array, but for a single element. It's useful in some pretty niche circumstances, but you know, it's there and it was easy to code, so I threw it in there. So that's a long path. Next, I'm going to talk about clip and mask. And if any of you are familiar with Photoshop, this is probably going to be fairly familiar. Essentially, you can kind of clip content to a path. If I take a star and plug a path in here, and I'm probably going to need to bump up the outer radius. Yeah, see, and I'm just going to throw this in here just to sample it. This spiral is clipped to the star, or the star's path. That is essentially the gist of it. It's just a way to kind of say where you want things drawn. Mask does something very, very similar, but instead of using a path to do it, it uses a shape. And where things get masked off is dependent on which mode you're using. So like mask mode of luminance means that things that are black will be masked out, and things that are white will be masked in, and grayscales in between are of partial opacity. And alpha uses the transparency of the mask shape itself. So like you could fill something with a medium gray, or you can fill something with any color, but if you set the opacity to 50%, then that means the mask will mask out the content at 50%. So it uses the transparency instead of the grayness of the mask element. It's essentially the same thing as clip, though, when you get right down to it. It's just slightly more flexible. However, there's a caveat here, which is not all SVG editors or interpreters will be able to handle mask or clip, so use that sparingly. I think there's wider support for clip than there is mask, but don't quote me on that. Next up is restyle. Restyle is a way to kind of take a shape and override the styles on it with some other set of styles. So like, I'm just going to take this circle that we have here that we've come to be familiar with, and I've got it wired up twice. So one is going directly to the layers and one is going through the restyle. One of the things I like to do with this actually is if I want to override the stroke width to 4 pixels, or 4 pixels, not 40. And I mean, obviously it doesn't look that great because it's overriding everything, but then I'll override the stroke dash to be like 4 pixels, 8 pixels. No, let's do 4 pixels. And then that's 1, 2, let's do 8 pixels, 4 pixels, 4 pixels, 4 pixels, and then 2000 pixels. Oh, missed one. There we go. So this gold bit is the overridden style. So it doesn't actually change the shape of the path at all, or the shape. It just kind of overrides the stuff that you would have in the appearance tab. This is really useful if you want to have a bunch of shapes have similar styles, or recycle a shape with different styles in different places. It's a good way to do that. Similarly, the transform overrides the stuff that is in the transforms tab with a few more options like skew and scale. So you can pipe a shape through transform to transform it again, or to have a shape be transformed in different ways by piping it through different transforms, which is, I think, fairly useful. You can also pipe a path through the transform the same way. These are independent channels, so like I could just like take a path and pipe it through that and I'll get the transform path. So that's the thing. So yeah, that's pretty much transform. I think I've covered everything here. Don't bother with compose a layer, that's pretty niche. Yeah, I think I've actually gotten everything now. So in the next episode, I will go ahead and make a subgraph. So stay tuned.